In previous class, we have discussed about problems on dynamically induced EMF, and types of induced EMF. In today's classes, we have to discuss about the main objective of today's class is nothing but the direction of induced EMF and current produced in conductor when it is moved in magnetic field. What are the induced EMF direction? What are the current direction? What are the current direction and induced EMF in a conductor when it is moved in magnetic field? And the direction of induced EMF and current. The direction of induced EMF and current produced can be stated by two laws. The direction of induced EMF and current produced can be stated by two laws. If the circuit is closed, the current is flowing. So here the direction of induced EMF and current is produced can be stated by the two laws. The first law is nothing but Lenz law. Second law is nothing but Fleming's right hand rule. Lenz law. So first law is nothing but Lenz law. What is the Lenz law? The Lenz law was proposed by the eminent scientist by the name Heinrich Friedrich Lenz. He was discovered and he was proposed Lenz law. He is a famous physics scientist. In 1933, formulated Lenz law. He is a Russian scientist. And a fundamental law of electromagnetism. The fundamentals of electromagnetism. He is a discovered. He is a proposed Lenz law. And he also found that the strength of magnetic field is directly proportional to the strength of magnetic induction. He is also discovered. He also proposed the another fundamentals is nothing but the strength of magnetic field is directly proportional to the strength of magnetic induction. So this is about the male Lenz. Next, what is the statement? What is the statement of Lenz law? What is the statements of Lenz law? What is the Lenz law? What is the law of Lenz? What is the relation between the induced EMF and current? It is stated that an induced current is always the flow in such a direction that it field opposed any change in existing field. An induced current is always flow in such direction that it is oppose very causes of its production. So this is the figures is indicate. The direction of current and induced EMF produced. The direction of relative conductor of motion. You have to observe this figure. The conductor is connected with the battery. So here the conductor is wound So here the circuit is the closed. When the switch will be closed, the switch is series with the battery and the conductor. If the switch is the closing, the electrons will be flows or current will be flows through the conductor. The current will be flows through the conductor. The EMF is produced. In a conductor. All we have to discuss in previous topic, that is the statically induced EMF and dynamically induced EMF. If conductor is a carry current or coil is a carry the current, the field is produced around the conductor. Or induced in that conductor, or the flux linkages in a conductor, the induced in that conductor. The EMF is produced in that conductor. So here the induced EMF is produced. This EMF causes motions. This EMF is causes to motions to oppose to the source current. So here the direction of current is the reverse. That is the to oppose the source current. So the explanation of Lenz law. What are the explanation of Lenz law? So applying Lenz law to the above figure 1. So this is the figure 1. We have to discuss now. Just now. So this is the conductors and this is the battery, and here the switch is there in figure A. So here the battery is connected in series with the switch and conductor. When switch is the closing from the battery, the current will be flows. Through the conductor. Then the induced EMF is produced. In that conductor. So here the conductor coil. Then this EMF is causes to the motions, and it creates the electrons, and which is the opposed to the flow of source current. So this is called as the Lenz law explanation. So here in that figure, when the north pole of magnet is brought towards the coil of n turns, the magnetic flux linkages in the coil is increases. Yes. So if magnet is there, so the magnet is the north pole of magnet is brought near to the n turns coil or n turns conductors. So one of the magnets we have to place towards the n turn conductors, near to the n turn conductors. Then from the north pole to south pole, magnetic lines of force will be moving. So due to this magnetic lines of force, the EMF is produced in a conductor. That means all you have to discuss in last class. So how to produce the EMF in conductor? How to produce either conductor are placed in the magnetic field, or the conductor which carry electric current. Okay. Got my point? EMF, if the EMF is produced, the induced EMF is produced in a conductor due to either conductor are placed in the magnetic field, or conductor which is the carry electric current. So here what we have to say here, when the north pole of magnet is brought towards coil of n turns, then magnetic flux linkages, the coil is increases. The magnetic flux linkages, the coil increases. Therefore, an the EMF, hence the current is induced. The EMF current is induced in the coil. According to the Faraday's laws of electromagnetic induction. According to the Faraday's laws of electromagnetic induction. But by Lenz law, we know that the direction of but by Lenz law, we know that the direction of induced current will be opposition to the causes producing it. According to the Lenz law, we know that the direction of induced current will be opposed to the causes producing it. Here the causes is increasing the magnetic flux linkage in the coil. That is, the induced current will be set up magnetic field. That oppose the increases in the magnetic flux through the coil. So that means here the induced EMF is produced in the coil. That induced EMF is opposed to the source current. Is called as the Lenz law. So this is the possible only if the left hand face of coil become north pole and the direction of induced current is found by the applying right hand rule for the coil. That is the direction of what are the direction of field, what are the direction of motions, what are the direction of electric current. So it can be found from by the using of Fleming's left hand rule. So here the Lenz law is nothing but the EMF is causes. So that induced EMF is produced in a conductor. The induced current can be opposed to the source current. So to the causes producing it. Hence here is causes the increasing the flux linkages in the coil. Only one point is there here. Only one definition is there. Whenever current flowing through the in a coil, it produces the induced EMF. This induced EMF is opposed to the source current. Next, Fleming's right hand rule. What is the Fleming's right hand rule? This law is used to find the direction of induced EMF. Hence, the current when the conductor move at right angle to the stationary magnetic field. Here we have to observe the figure here. Here N and S pole is there. So the magnetic lines of force will be moved from north pole to south pole. If the conductor are placed in the magnetic field, the EMF is produced in the conductors. So it will be causes in the motion in the conductor. That means the conductor will be deflect. And conductor will be move. So if the conductor are placed in the magnetic field, what are the direction of motions, what are the direction of field, what are the direction of current, we have to discuss now. So this law is used to find by the using of this law we have to find the direction of induced EMF. Hence the current when the conductor is moved at right angle to the stationary magnetic field. Here we have to put here the forefinger. We have to put the right hand perpendicular, three fingers, the thumb, four fingers and middle fingers is perpendicular to the each other. So here perpendicular each other. So here the thumb, the four fingers is middle fingers, and thumb of right hand is held perpendicular to each other, So here the three fingers of right hand, right hand shown in figure. So you have to observe in the figure, then you have to perpendicular to the each other. Okay, now right hand of three finger, that is the thumb, forefinger and middle finger, held perpendicular to the each other, perpendicular to the each other. So here in this in these three fingers, the forefinger point in the direction of magnetic field, you have to observe that the direction of magnetic field and this hand. Okay, now so north pole to south pole, the magnetic lines of force will be moving, from the north pole to south pole. So here the forefinger, so this is the B. Okay, now blue color line. The forefinger is indicate the direction of magnetic field, Okay, now and the thumb is shows the direction of motion of conductor. That is the motion of conductor of the direction. The thumb is indicated the direction of motion, in the conductors of the conductor, Then the middle finger is indicate the point in the direction of induced current. Okay, now here the current is the deflecting, the induced current is produced in the conductor, that induced current is the produced in the conductor. According to the Lenz law, the induced current is produced in that conductor. So that is the middle finger is indicate the direction of current, induced current. The middle finger is indicate the direction of induced current, So this is called as the statement of Fleming's right hand rule. Okay, now so here what are the Fleming's right hand rule? The thumb is indicate the thumb and forefinger and middle finger of right hand to put or are held perpendicular to each other, You have to observe in the figure, and you have to compare to the right hand figure and magnetic lines of force figure. So you have to compare this one, then you have to easily understand. So perpendicular to the each other, then the forefinger, the blue line is indicate the direction of magnetic field, that means magnetic lines of force from north pole to south pole. Magnetic lines of force will be moved from north pole to south pole. And the thumb, that is the green line, that is the thumb is indicate the direction of motion, that is the force will be causes in the conductors. And the red color, that is the middle finger, is indicate the direction of induced current. Due to the motion of magnetic lines of force, then the induced EMF produced in that conductor, then the conductor will be deflected, moved in the magnetic field, So here the motion is causes upwards, that the force is causes upwards, and induced current will be flows through the conductor. So that current will be flows through the load. Here if the load is connected with the bulb, then the bulb will be glow. So you have to easily understand to the direction of induced current and motion of magnetic field and the direction of magnetic field. So here the forefinger, the forefinger is indicate the direction of magnetic field, and thumb shows the direction of motion of conductor, and middle finger is indicate the direction of induced current, the direction of induced current. So here the explanation also given. Here the explanation also given here. So let the conductor let the conductor A and B move upwards at right angle to the uniform magnetic field shown in figure. So you have to observe the figure 2. Let the conductor AB move upwards right angle to the uniform magnetic field shown in figure. By the applying Fleming's right hand rule, the direction of induced current is from B to A. Here the direction of magnetic field you have to observe in figure B. You have to observe in figure B here. So here, so let us the conductor A and B. So here the conductor A and B. So move upward. That is the motion is causes in the conductor. The motion is causes in the conductor is upwards. So the thumb is indicate the direction of motion. Upwards at right angle to the uniform magnetic field shown in figure 2. By the applying Fleming right hand rule, the direction of the induced current is from B to A. In this figure we have to observe the B to A, the direction of current, induced current. That is the indicated with the middle finger. Next, but the conductor is moved downward the direction of induced current A to B. That is the direction of current conductor A to B. That means the motion is causes is downward. The direction of motion is downwards is there. Then the direction of current is the A to B. If the direction of motion is upwards, then the current direction is the B to A. So this is the by the applying of Fleming, according to the Fleming's right hand rule, you can easily to find the direction of induced current and motion and motions of induced EMF. Forces are motions due to the conductor or coil placed in the magnetic field. The motion is causes or force is causes in that conductor. Then the induced current will be flows in conductor or coil. So here in this class we have to discuss about the direction of induced EMF, and hence the current is produced can be stated by two laws. First law is nothing but Lenz law, and second law is nothing but Fleming's right hand rule. So this topic we have to discuss in this period. Some quiz question is given here. So very usable to you. So here first question is nothing but the direction of induced current. Induced current produced in a magnetic field can be found by option A is nothing but Faraday's law, option B is nothing but Coulomb's law, option C is nothing but Lenz law, option D is nothing but Ohm's law. So here option C Lenz law is correct answer. Next, some frequently asked question is given here. First question is nothing but states of Lenz law. What are the states of Lenz law? State is nothing but the definitions and some explanations also. So definitions and explanations we have to learn, and we have to know that the states of Lenz law. Next, second question. Explain Fleming's right hand rule. Explain Fleming's right hand rule. Okay, now what are the explanation of right hand rule? What are the use of right hand rule? What are the use of right hand rule? So what are the use of right hand rule? What are the use of right hand rule? You have to explain briefly with the figure also. so that is the explain Fleming's right hand rule. Explain Fleming's right hand rule and the Lenz law. So this is we have to, it can be we have to able to learn, and we have to discuss in today's topic about Lenz law and Fleming's right hand rule. Lenz law and Fleming's right hand rule. So the Lenz law formula is there. That is the E equal to minus of N into d pi by dt also. That is the induced EMF produced according to the Faraday's laws of electromagnetic induction. According to the Faraday's laws of electromagnetic induction, that is the second law. That is the second law. What are the second law says? What are the second law state that magnitude of rate of change of flux linkages in a conductor. Magnitude of rate of change of flux linkage in a conductor. So that is called as the Faraday's second law. What is the Faraday first law? What is the Faraday first law? Faraday first law is nothing but whenever conductor are placed in the magnetic field, the induced EMF is produced. The induced EMF is produced in the conductor. Next, are the conductor which is carry the electric current. The conductor which carry the electric current. Then the EMF is induced in the conductor. The EMF is induced in the conductor. What is the second law? That induced EMF, how much? That is, what is the magnitude of that induced EMF is produced in a conductor? That is the magnitude of induced EMF produced in a conductor. So that induced EMF is equal to E equal to minus N into d pi by dt. Minus of d pi by dt. So that is nothing but here N is the number of conductor, d pi nothing but change in flux due to conductor are placed in the magnetic field, or the current is changing, or current is changing in the conductor with respect to the time. So the Lenz law formula is nothing but E equal to minus of N into d pi by dt. So that is also formula is there for the Lenz law. Formula is there from Lenz law. E equal to that is the induced EMF is produced, which is causes to oppose the flow of source current. Oppose the flow of source current. So here that is the induced current. That is called the induced current. Initially the EMF is produced in a conductor due to the current flowing through the conductor, or conductor placed in the magnetic field, then the EMF is causes. Thus EMF is called the induced current. That is EMF is called induced current. That induced current is to oppose to the flow of source current. So here the Lenz law and Fleming's right hand rule we have to discuss in today classes. So we have to read and prepare, then we will understand easily. Just we have to observe this figure and this figure. For the Lenz law we have to observe this figure. For Fleming's right hand rule You have to observe this figure, then you can understand easily. Okay, thank you.